2020, question 9. Finish off the paper with a nice easy one. We're given this function, it's the growing number of bacteria, and we all know these. T is time, 450 is going to be the initial amount, E is in all of these, 2.718, and we have B up here, or K sometimes it's called, and we're asked to find the number of bacteria in the colony after 4.5 hours. T is 4.5, so simple calculator used here. 450 E to the power of 0.065 by 4.5, and put it exactly like this into your calculator, and you're going to get 602.898 round it, and we're asked to the nearest whole number, so that's going to be equal to 603. Find the time in hours. So now we're looking for T, and we're looking for the indicate. We know it's going to be logs. So if you practice these questions, you see them, you know exactly what's going to happen. That's how the students who do really well just fly through these tests. Preparation is key. So it takes to grow the colony, we're told that the amount is 790, and give your answer to one decimal place. So if I just write the formula out again, 450 E to the power of 0.065 T has to be equal to 790. So the same procedure in all of these. We're going to divide across by 450 to get E. Well, I can knock off the divide across by 10, so I'm going to get E to the power of 0.065 T is equal to 79 over 45. So if we say, if we get the natural log of both sides, 0.065 T by the natural log of E, which is equal to 1, is equal to the natural log of 79 over 45. And this is equal to 1 here. So we're just going to divide by 0.065. So T is equal to the natural log of 79. Actually, I'll get the natural log of 79 over that when I'm at it. That's going to be 0.56278, 0.56278. And I won't round it on the calculator. I'll divide the big long decimal by 0.065. And my time comes out at 8.658. And is it one decimal? One decimal. So 8.7 hours. So with these questions, there's only certain things they can ask you. When you practice them, you're rubbing your hands together under the desk saying, yes, H1 all the way. Part B to this question, same function. Find the average number of bacteria. So the average value 1 over B minus A is the key to this one. We integrate the same way when T is between 12 and 3. So we're integrating between 12 and 3, 450 E to the power of 0.065 with respect to T. So dt. And when we integrate E to the power of AX, it goes to 1 over A. E to the power of AX. So whatever's in front of my T here, it's going to go on the bottom. So we're going to end up with 450 E to the power of 0.065 T times 1 over 0.065, and that's going to be between the bands 12 and 3. We're going to get the average value of it between those 9 bands, 1 over 12 minus 3, which is going to give me a ninth of this whole value here. So it's going to be 450 E to the power of 0.065 T divided by 0.065 between these two bands. So we fill them in and use our calculator. We get 1 over 9, 450 E to the power of 0.065 times 12 divided by 0.065 minus E to the power of, 450. I could have factored out the 450, but I'll leave it here. 450 E to the power of 0.065 times 3 divided by 0.065. And on a calculator, I rounded off too early the first time. It gave me 743.5, so I just took a couple more decimals just to be sure, and it's actually 743.2. And I think this one's to the nearest whole number, so I just make sure in the calculator not round too early. 743 is to the nearest whole number for this colony between those hours. Now find the rate. So we have a rate of change question. When t is equal to 12, answer 1 dp and interpret this value in the context of the question. Easy one to correct. So rate of change is differentiation. So n prime t. So it's going to be 0.065 brought in front times 450 e to the power of 0.065t. That's differentiation. I can multiply the two constants here to get 29.25 e to the power of 0.065, and I'm putting t to be 12. And I type this into a calculator. A lot of calculator use on this paper. I'm going to get 63.8, and interpreting this in the context of the question. Well, it's the rate of change question. So what's happening here? The rate of change is bacteria increasing at, does it give us any information about the bacteria other than the basics, just bacteria? So it's increasing, they're starting to grow, and at any time t, so we've just got for t12, so the bacteria are increasing at a rate of 63.8 when t is equal to 12. And then part D, after k hours, the rate of increase is greater than 90 bacteria per hour. Greater than 90. Find the least value of k, and k is an element of natural numbers here. So the rate of increase is my differentiated function. What did I get? 29.25. 29.25 e to the power of 0.065t has to be greater than 90. So another log question. N prime t is equal to this. So if I divide across by 29.25, I'm going to get 90 over 29.25, just under 3. Just over 3 even, so it's 3.07. I'll leave that as 90 over 29.25. So now I'm going to get the natural log of both sides. 0.065 t by the natural log of e, which we know is equal to 1. You could leave it out. Has to be greater than the natural log. I shall decimalize it. I've got 3.0769, 3.08. I'll round it to 3.08. So t is greater than the natural log of 3.08 divided by 0.065. So t is greater than, that's going to give me 17.306, 17.3, and we've just used t in this question. T is equal to k. They're looking for k here, and k is a natural number, so k therefore is equal to 18. And to the last part of this question, the last part of the 2020 exam. Hopefully you had the patience to stick with it. So the number of bacteria in a different colony can be approximated using the function 220e to the power of 0.17t and the same number of p of t and t in hours. Both colonies start growing at the same time. Find the time to the nearest hour, so we need t, another log question, in which the number of bacteria in both colonies will be equal. Okay, they're going to be equal. 220 e to the power of 0.17t has to be equal to 450 e to the power of 0.065t. I can divide by 10 straight away, and I'll use the indice. What we're going to end up with here is e to the power of t underneath e to the power of t, so we're going to use the rule of indices. So I'm going to put the bigger e to the power up on top. So I'm going to divide by 22. So e to the power of 0.17t, and I'm also going to divide across by this guy, divided by e to the power of 0.065t. That's going to be equal to 45 over 22. Using my rules of indices here, I'm going to get e to the power of 0.17 minus 0.065 times t. 22, 170 minus 65 is 105, so e to the power of 0.105 t is equal to 45 over 22. So natural log of both sides, 0.105t by the natural log of e, which is equal to 1, is equal to the natural log 45 over 22. Be careful to get the natural log of both sides, easy to forget. So t, with this guy being equal to 1, is equal to the natural log of 45 over 22, with my dog snoring in the background, divided by 0.105, and that's going to be equal to 6.8 hours. And I think, are we asked to the nearest hour? To the nearest hour. So we're looking at 7 hours here until they are equal. End of 2020.